Mr. Van Hong here with week 9, day 2 essential math instruction. And today we're going to talk about adding and subtracting fractions, okay? So adding and subtracting fractions in 5th grade, the way that we focused on doing it, in 4th grade, you made lots of models to do this. And in 5th grade, we said, hey, look, we're going to make common denominators and we're going to add or we're going to subtract. Remember that the parts of a fraction are the numerator on the top and the denominator on the bottom. The denominator on the bottom is telling you how many slices it takes to make a whole cake. The numerator on the top is how many slices you have. So 1/2 is it takes 2 slices to make a whole cake, and you have 1 slice. So that's an important thing to remember. We need to have our cakes cut the same way in order to add and subtract fractions, right? If I say I eat a slice of cake and you eat a slice of cake, if the cakes have been cut in different ways, we can't really compare those numbers. We can't add them. We can't subtract them. We need our cakes to be cut the same way. So we're going to see problems today that have unlike denominators, and we're going to change one or both of the fractions so that there is a common denominator. We don't care about if it's the least common denominator or not. We don't care about simplifying at the end. We care about finding a common denominator and then adding or subtracting. So let's just make up a problem right now. Let's say that I eat 1 slice of a cake and you eat 1 slice of a cake as well. And we're trying to say how much total cake did we eat. Now, our cakes have been cut differently. So what we need to do is we need to imagine them cut the same way. I mean, we could draw a picture of this. There's nothing wrong with drawing 1/2 and drawing 1/3 and then creating a common denominator with that too. But ultimately, we are trying to rewrite this problem so that there is a common denominator. So I look at 2 and I look at 3, and I'm lazy. And so the first thing that I always ask myself is, can I get away with just changing one of them? Does 2 go into 3 so I could just change 1/2? Or does 3 go into 2 so I could just change 1/3? And in this case, the answer is no. I can't get away. Like if this was 1/2 plus 1/4, I'd be like, I only have to change 1/2 into 4ths and I can leave the 4ths alone. But that's not the case. So I'm going to change both of them. So I like to draw it like this. And I think Mr. James doesn't quite do it like this, and that's fine. I think, and I know the math book had you write equals and then rewrite it over there. And that's fine. I don't care how you write it. I like to do it like this so that I'm kind of putting them in columns. I'm saying I'm going to rewrite 1/2 right here. I'm going to rewrite 1/3 right here. And these are equivalent fractions. I'm not going to change the value of 1/2. I'm going to change the way that I'm talking about it. So instead of talking about 1/2 of a cake, I'll talk about a different amount. Now, we need to find a common denominator. So I need to ask myself, what do both 2 and 3 go into? What can I multiply to? Or once I'm thinking of the multiples of 2 and 3, what do they go into? And some of you might be remembering right now that you can always find a common denominator by multiplying the denominators together. And that's true. And because we don't care about simplifying, you can always do that. You can always just be like, well, I'm going to use the 2 denominators times each other, which is 6. And in this particular case, that's also the least common denominator. But again, it doesn't matter. How did I get from 2 to 6? I show my work by noting that I multiplied 2 by 3 to get there. And then I'm going to write it again to make sure that I understand, and I'm showing that I understand. I also have to multiply my numerator by 3. So 1 times 3 is 3. So 1/2 is the same thing as 3/6. Just as a quick review, I'm going to prove to you that that is true. There's a 1/2, and there are 3/6. It's the same amount of cake in my stomach. So that's 1/2 becoming 3/6 in a picture there. So that's why that works. As long as you multiply the top and the bottom by the same number, you get an equivalent fraction. You don't change the value. You're just changing how that cake has been sliced. Now over here, how do I get from 3 to 6? I multiplied by 2. So what do I need to do to the top? Also multiply by 2. You should take the time to write it. You really should. Make sure that you show your understanding of that. 1 times 2 being 2. So now I've got 3/6 plus 2/6. When you're adding and subtracting with fractions, once there's a common denominator, that denominator doesn't change again, and just the numerators interact together because we're no longer changing this how many slices it takes to make a whole. We're just talking about how many slices we have. I ate 3 out of 6 slices. You ate 2 out of 6 slices. We ate a total of 5/6 of that ice cream cake. So that would be our final answer here is 5/6. Now let's just quickly imagine that instead of this, we were subtracting. If this was a subtraction problem like this, It's the same steps. We still, if we're going to say who ate more, how much more did Mr. Van Dong eat than you, then we're going to need to compare these numbers with a common denominator. So we would go through the exact same steps, except now it's subtraction. My 3/6, take away the 2/6, is going to leave 1/6 left over. So we could say I ate 1/6 more than you did, 1/6 of a cake more than you did. Not supposed to laugh at students. So yeah, that's the addition and subtraction of fractions. However, there are times when you're going to be doing mixed numbers. Remember that a mixed number is when you have a whole number and then you have a fraction next to it. So something like this. If we're doing 3 1/3 plus 2 and I don't know, 3/4. Then it's the exact same process. Basically, I'm going to create common denominators. My whole numbers stay the exact same. I'm still going to have over here 3 and something plus 2 and something. What common denominator should I use? I can just do 3 times 4 is 12. I can use 12s, and in this case, that's the least common denominator, but it really doesn't matter. How would I get from 3 to 12? I multiplied by 4, so I better do that to the numerator as well. 1 times 4 is 4. I'm not changing anything about the 3. This means 3 whole ice cream cakes and 1/3 of another ice cream cake. I'm not changing how much ice cream cake there is over here. I'm just changing how it's been cut up. So there's still 3 whole ice cream cakes, and instead of talking about 1/3 of an ice cream cake, I'm not now talking about 4/12 of an ice cream cake. Over here, I've got to multiply the bottom by 3, so I have to multiply the top by 3. So now I still have those 2 whole ice cream cakes, and those 3/4 I'm now thinking of as 9/12. Now these interact just like you would expect. How many make the whole numbers interact first? So I've got 3 plus 2. That's going to make a total of 5 whole ice cream cakes. And then over here, I've got 4/12 plus 9/12, which is going to be a total of 13/12. Now, this is not an acceptable final answer. I know I just said I don't care about simplest form. This isn't about simplest form. You're not allowed to have a mixed number, a whole number next to an improper fraction like that. You can have just an improper fraction or just a whole number, but we never are allowed to leave a number like this, where we've got a whole number and an improper fraction. So in this case, I need to think about, well, if I have 5 whole cakes and I have 13/12 of another cake, I'm going to draw the 13/12 and then figure out how many holes that is and what's left over. So 13/12 real quick. So I can do, there's 1, 2, 3, there's 12s, right? Yeah, that's 12s. So I've got 12/12 right there. And then again, I need 12s. 1, 2, 3. And then here's my 13th 12. So I've got 12/12 and I've got a 13th 12th over here. So I've got one more whole cake, right? That's one more whole cake. So this becomes, I still have those 5 whole cakes, which I didn't draw. And then there's one more whole cake. So that's a total of 6 cakes. I've taken care of that. And then what's left over? Another 12th of a cake. So that's a total of 6 whole cakes and 1/12 of another cake. If this was subtraction, I would have to regroup. So we're going to rewind again. So we're going to imagine this was subtraction. This will be the last example that we do. It's going to start all of the exact same way. Now we're trying to find the difference between these numbers. So now I've got this going on. And now I've got a bit of a problem. Yeah, I could do 3 minus 2 is 1 whole cake, but I can't do 4/12 minus 9/12, can I? If I have 4/12 of a cake and you try to take 9/12 from me, I'm going to run out. You're going to take all 4/12. I'm going to owe you 5 more 12s. So that doesn't work out yet. But this is a bigger number, right? 3 and 4/12 is bigger than 2 and 9/12. So I should be able to make this work out. What I need to do is take one of these whole cakes and put it over here. So I'm going to temporarily do what I just said. Our final answer can never be a whole number and an improper fraction next to each other. But as we're working, we can do that. So what I'm going to do is I'm going to take away one of these whole cakes. So now I've just got 2 whole cakes, right? And I'm going to cut that whole cake up into 12s. And now I have 12 more 12ths of a cake. So I've got these 4/12 of a cake and another 12/12 of a cake. That's 16/12 of a cake. So 3 and 4/12 is the same thing, same amount as 2 and 16/12, which you can draw with a picture too. Now I'm ready to subtract these numbers. So I've got 2 minus 2. Oh, that's nothing. And 16/12 minus 9/12, oh, I have an instinct that I've made a mistake, but maybe I haven't. I don't know. That's 7/12. So there's 7/12 left over. So if you have 3 1/3 cake and somebody eats 2 3/4 of the cake, now you have 7/12 of the cake left, which you could also solve with pictures. So again, your steps here are create a common denominator and then make them interact. It only really gets tricky when you've got mixed numbers, and it's only sometimes when you've got mixed numbers that it really gets tricky, especially if you have to do some borrowing. So watch out for problems like that. Do your best, and I will talk to you tomorrow.